In this video, let's dive into traits in Rust, which allow you to define shared behavior for different types. A trait is like an interface in other languages. It defines a set of methods that types can implement. You can implement a trait for a specific type by defining the methods inside an impl block. Traits can also be used to define function parameters, ensuring that the argument implements the required trait. To make generic functions more flexible, you can use trait bounds to specify that a type must implement a certain trait. Traits can also provide default method implementations, allowing you to override only specific methods if needed. That's a quick look at working with traits in Rust. Stay tuned for more Rust programming insights. In this video, let's explore generics in Rust, which allow you to write flexible and reusable code for different types. Generics enable you to define functions, structs, enums, or methods that work with any data type, ensuring type safety. Let's look at how to define a generic function. The largest function here works with any type that implements the partial or trait. Generics can also be used in structs. Here's a struct point that can hold any type. Enums can also use generics to handle different types. Here's an example with the option enum, ensuring they implement certain behavior. That's a quick overview of generics in Rust. Stay tuned for more Rust programming insights. In this video, let's explore impl blocks in Rust, which allow you to define methods and associated functions for your types. An impl block is where you implement methods for a struct or enum. It's how Rust enables object-oriented programming. Inside an impl block, you can define methods that operate on the data inside a struct. These methods take and self as a parameter. You can also define associated functions, which don't need an instance of the struct. They're often used as constructors. Rust allows you to have multiple impl blocks for the same type, helping organize your code better. You can also implement traits for your types using impl blocks. Here's an example implementing display for rectangle. That's a quick overview of impl blocks in Rust. Stay tuned for more Rust programming insights. In this video, we'll explore trait bounds in Rust, a feature that allows you to specify what traits a generic type must implement. Trait bounds are used in generics to ensure that a type implements a specific trait, enabling certain behavior in your code. Here's a simple function that requires the generic type to implement the display trait, which allows it to be printed. You can also specify multiple trait bounds to require that a type implements more than one trait. When there are many trait bounds, you can use a where clause to make the code more readable. Trait bounds can also be applied to structs. Here's an example where a generic struct can only hold items that implement display. That's a quick look at trait bounds in Rust. Stay tuned for more Rust programming insights. In this video, let's explore closures in Rust, a way to create short, anonymous functions. A closure is a function-like construct that you can define in place and can capture variables from its surrounding environment. Closures can capture variables from their surrounding scope, which makes them flexible. Rust can infer the types of parameters and return values for closures, making the syntax concise. You can pass closures as arguments to functions, allowing for more functional programming patterns. Closures can borrow, mutate, or take ownership of captured variables, depending on how they're used. That's a quick overview of closures in Rust. Stay tuned for more Rust programming insights. In this video, let's explore iterators in Rust, which allow you to process sequences of data efficiently. An iterator in Rust is a trait that allows you to process elements from a collection one at a time. Rust provides common iterator methods like next, right single quote, map, right single quote, and filter, right single quote for transforming and processing data. You can also use a for loop to iterate over a collection, which automatically consumes the iterator. Rust allows you to chain iterator methods to perform multiple transformations in a single line. You can also create custom iterators by implementing the iterator trait and defining the next, right single quote method. That's a quick look at iterators in Rust. Stay tuned for more Rust programming insights. In this video, let's explore how to work with for loops and iterators in Rust for efficient data processing. A for loop in Rust is the simplest way to iterate over a collection like arrays or vectors. Under the hood, the for loop uses the into-iterator trait, which converts collections into iterators. You can chain iterator methods like map and filter to transform data during iteration. You can use iterators directly in for loops, giving you more control over the iteration. You can iterate by reference iter, by mutable reference iter mut, or by value into underscore iter, depending on how you want to use the data. You can create custom iterators and use them in a for loop by implementing the iterator trait. That's how you work with for loops and iterators in Rust. Stay tuned for more Rust programming insights.